Hi, in this video we are going to discuss about array implementation of list, and already we have done 4 operations, that is full, check whether the list is full, list is empty, and creating a list and destroying the list in C++. And also we discussed in the previous video that it is possible to have the constructor itself for creating the list and the destructor for destroying the list. That makes sense, right? And in this video we are going to talk about implementing the insert beginning operation. So how we can do? First we will write an algorithm, understand it, and then we will go for implementation. So the first step that we are going to do is basically we are going to check whether the list is full, right? For all the insertion operation, it is a must that first you should check if the list is full. If the list is full, then you return false. You have nothing to do with that. Otherwise, you are going to the step number 2. Since these algorithms are just functions, I just give in return and I do not have a else. Okay. So if it is coming to step 2, it means that step 1 was not true, right? In this case, if the list is empty, then place the new element as the first element and increment the number of elements in the list, and you are going to return true. Actually, the return value of the operation is going to say whether it has been done successfully or not. Okay. So I am going to have like a boolean. In algorithm I am telling it as boolean. I will tell if the operation was successful, I am going to return true, otherwise I am going to return false. During implementation, let us see how we can do, right? And this is a special case that we are talking in algorithm. In implementation it may not be required, that we will see. And step number 3 is, what is step number 3? If there are already few elements and you are going to insert the new element in the beginning of the list. In that case, what should be done? You have to create an empty space in the beginning of the list by shifting all elements right by one place. Okay, you have to shift one place right and place the new element in the beginning and increment the number of lists. Always we should remember that we should increment the number of lists in the number of elements in the list, then only our algorithm will work. Let us just assume I give an analogy for what we were discussing. Assume that there is a room and there are 5 chairs and people will be coming and sitting, right? Already there are 3 people seated. Now a new person enters in and you want to make the new person to sit on the first chair, okay? And there is a constraint that only one person can move at a time. I repeat again, there is a constraint that only one person can move at a time, and you want to make the first person to sit in the first chair, and you cannot ask the first person to go and sit in the fourth chair, nothing like that. A person can shift only one position at a time, okay. So what we will be doing, we will be asking the last person to occupy the next chair and the third person to come here and the first person to come to the second chair, so that the first chair is empty, the new person come and sit, right? This is how we will be doing. If all the 5 chairs are full, if a new person is coming, then you will tell the hall is full. Maybe he has to move to next hall or something like that, okay. So when you look at this particular thing, actually the time taken, the person who is entering into the room, the new person who is entering into the room has to wait till all the 3 persons, if there are 3 persons, all the 3 persons have shifted their positions and have made the free space, right? So he has to wait, so the time taken will depend on the number of persons. Assume if you have got a larger hall, and if there are some 20 people already there and 21st person comes, then he has to wait till all the 20 people has moved, right? This depends on the number of people already inside the hall, okay. And this is going to be called, or this is how we will be measuring something called as time complexity of the algorithm or of the operation. Since it depends on the number of people already in the chair, we will use big O notation to represent. We are not going in depth into the algorithmic analysis. We will be doing only simple analysis on the algorithms whatever we discuss. So here we will tell that the time complexity is going to be big O of n, because it depends, this operation, time taken by this operation depends on the number of people already inside the room. That is, for example, let us assume that it takes 1 second for one person to shift the position. If there are three people already in the hall, then the new person has to wait for 3 seconds. If there are already 10 people in the hall, then the new person has to wait for 10 seconds and so on, right? So, when we look at it, when there are 3, he has to wait for 3 seconds, 10 seconds, 100 means he has to wait for 100 seconds and so on, right? So, there is a linear relationship between the number of people and the time he has to wait. So, it is big O of n. That is how we will relate. Actually, big O of n means that the time taken by the algorithm will be less than or equal to n, right? Need not be equal to, always not strictly equal to, it will be less than or equal to n, right? So, let us go back to the implementation. Now, we are going to, already we did this in the previous session, you can see here, and now we are going to add one more operation, insert beginning. As I told you, you are going to use the return value for indicating whether the operation was successful or not. Since this is a OOP programming, we will call the insert beginning function through the list in which it has to be inserted, right? So, we will be just passing only the element that is to be inserted, okay. So, declaration is done. Let us move down and start the implementation, okay. So, bool and it's inside, sorry, bool and then list and then insert beginning x, okay. And what we have to do now, we have to check if the list is full. So, let us call the already returned function is full, okay, if not of is full, right, or if is full. If the list is full, then you are going to return false, right, otherwise you are going to proceed. And in C++ we can declare variables wherever you want, but it is a good practice to declare it in the beginning of the function itself. So, have declared it in the beginning of the function. Now, where should we start? What did we do? We started from the last person. We asked first the last person to shift to the next place. So, where is the last element? Actually, I can locate the last element in the position number of elements -1, right, and I will go till the first person, right. The first person has to shift the place. So, I is greater than or equal to 0, and when you look at it, I am going to move in the reverse direction for each iteration. So, it should be I minus minus. Now, I will be telling elements of I plus 1. Actually, the new person, the last person or each person has to move to their right, okay. So, I should say elements of I plus 1 is equal to elements of I, and one more thing, I should increment the number of elements, right. This is done, and after doing all these steps, let me return true because it is a successful insertion. There was a space, so the new element is inserted, okay. I have not inserted it actually. I have to tell elements of 0, right, equal to x, then only I am making the new person to sit, right, that I have to do. I missed that, I added now. So, now insert beginning is also ready. Let me remove this one here. So, what I am doing, I am reading the capacity of the list, and you are creating a list for the required capacity, and then you are checking whether it is empty, whether it is full, and after this we are going to insert, right. Insert beginning, okay, of 3. Let me tell 3, and then let me call again insert beginning 2, okay. So, what will happen? First 3 will be in the first char, okay, and when I call L dot insert beginning of 2, 3 will be moved to the second char, 2 will occupy the first char, something like this, okay. When I am telling insert beginning of 1, now 3 will be moved to the third char, 2 will be moved to the second char, and 1 will occupy the first char. If the capacity I am going to give as 3, after this the list is full, isn't it? So, I am going to just check, okay. Always return values can be ignored. You might have noticed that I did not use the return value, but if required I can use it. So, now I am using it. I am checking whether the insert beginning is returning a false. If it is returning a false, then what I am going to do, I am going to print insertion failed. Okay, let me print insertion failed and move to the next line, right? Okay, so this is the code that's returned, and yeah. Okay, so let us invoke the G++ compiler and invoke insert beginning. Yeah, let us see. We have to call it through the object. I missed it. I have just given insert beginning. That was the mistake. Yes, the code has compiled, and let us give 3. So you can see that 0, 1. Actually, it is reading 3. Why it is printing 1 is because the list is empty. So is empty returns true. True is 1. That's what is getting printed. 0 because is full is checked and the list is not full. So it is printing 0. Now after inserting the 3 elements, let me print the list. Okay. Let us try. Yes. So now you can see that the elements are inserted correctly. 3, 2, 1 is available, and you will see that when I try to insert the 4th element, I am getting a failure message since there are the capacity is given as only 3. Okay. So I will be sharing this code in the GitHub. You can take it and you can also try out printing after each insert operation and so on. Thank you.